According to 240.33 of the 2002 National Electrical Code, or NEC, circuit breaker enclosures can be installed horizontally if they comply with 240.81. Let's examine what this means for practical installations, particularly concerning panel boards. Section 240.81 of the NEC addresses the orientation of circuit breaker handles. It states that when circuit breaker handles are operated vertically, rather than rotationally or horizontally, the up position of the handle must indicate the on position of the breaker. This requirement has specific implications for how panel boards can be mounted and used. Consider a typical panel board. These are usually installed vertically. In such a configuration, the circuit breakers are arranged in two rows, with their handles operating horizontally. If you were to install this standard panel board horizontally, one of the rows of circuit breakers would violate the requirement of 240.81. In this scenario, the up position of the breaker handle would not correspond to the on position for all breakers in that row. Therefore, the NEC does not permit the horizontal installation of a standard panel board that is designed for vertical mounting with horizontally oriented breakers. However, there is an exception. Panel boards that are designed with vertically installed breakers are permitted to be mounted horizontally. When these panel boards are installed horizontally, the vertically oriented breakers become horizontal. But critically, the up position of the handle still corresponds to the on position. In other words, the intention of 240.81 is preserved because the breaker's intended operational orientation is maintained. To summarize, the NEC allows horizontal mounting of circuit breaker enclosures only if they adhere to 240.81. For standard panel boards with horizontally oriented breakers, horizontal mounting is prohibited because it violates the up equals on rule. Panel boards with vertically oriented breakers, however, can be mounted horizontally because the up equals on rule remains valid. This distinction is essential to ensure safe and code-compliant electrical installations. Understanding these requirements prevents potentially dangerous misoperations of circuit breakers, promoting electrical safety. Remember always to consult the latest edition of the NEC and local amendments. Also, it is important to seek guidance from a qualified electrical inspector or engineer to ensure full compliance with all applicable regulations. Consider also the broader context of electrical installations and circuit breaker applications. Circuit breakers are designed to protect electrical circuits from overcurrents, which can result from short circuits, overloads, or ground faults. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to equipment and potential hazards such as fires. Proper installation and orientation of circuit breakers are therefore crucial for their effective functioning. The NEC provides comprehensive guidelines on various aspects of electrical installations, including the selection, installation, and protection of circuit breakers. These guidelines are based on sound engineering principles and practical experience, and they are intended to ensure the safety and reliability of electrical systems. In addition to 240.33 and 240.81, other NEC sections relevant to circuit breaker installations include those covering overcurrent protection, conductor sizing, and equipment grounding. It is important to be familiar with these sections and to apply them correctly in order to achieve a safe and compliant installation. Furthermore, it's crucial to consider the specific requirements of the equipment being protected by the circuit breakers. Different types of equipment have different current and voltage ratings, and the circuit breakers must be selected accordingly. The equipment manufacturer's instructions typically provide guidance on the appropriate circuit breaker size and type. Failure to properly size and select circuit breakers can result in equipment damage, fire hazards, and even electrical shock. In conclusion, the NEC provides detailed requirements for the installation and orientation of circuit breakers in order to ensure the safety and reliability of electrical systems. Compliance with these requirements is essential for all electrical installations, and it is the responsibility of electricians, engineers, and inspectors to ensure that they are properly followed. Understanding the specific requirements of 240.33 and 240.81, as well as other relevant NEC sections, is crucial for achieving a safe and code-compliant installation. Furthermore, it is important to consider the specific requirements of the equipment being protected by the circuit breakers and to select and size them accordingly. By following these guidelines, you can help to ensure the safety and reliability of electrical systems and prevent potentially dangerous hazards. Moreover, consider the practical implications of these code requirements in real-world installations. For example, when designing an electrical system for a commercial building, the architect or engineer must carefully consider the layout of the panel boards and the orientation of the circuit breakers. If space constraints or other factors make it necessary to install panel boards horizontally, it is essential to select panel boards with vertically oriented breakers in order to comply with the NEC. In addition, the electrical contractor must ensure that the panel boards are properly installed and that the circuit breakers are correctly labeled and identified. This is particularly important for maintenance and troubleshooting purposes, as it allows electricians to quickly and easily locate and operate the correct circuit breaker. Regular inspections and maintenance of electrical systems are also essential for ensuring their continued safety and reliability. During these inspections, it is important to check the condition of the circuit breakers and to verify that they are functioning properly. Any damaged or malfunctioning circuit breaker should be replaced immediately. Furthermore, it is important to keep panel boards clean and free of obstructions, as this can help to prevent overheating and other problems. By following these best practices, you can help to extend the life of electrical systems and to minimize the risk of electrical hazards. Remember that electrical codes and standards are constantly evolving, and it is important to stay up to date with the latest changes. This can be achieved by attending industry conferences, reading trade publications, and participating in continuing education courses. By staying informed about the latest developments in electrical technology and safety, you can ensure that you are providing the best possible service to your clients and customers. Also, when dealing with electrical installations, remember to prioritize safety above all else. Always wear appropriate personal protective equipment, such as gloves and safety glasses, and follow lockout/tagout procedures to prevent accidental energization of circuits. Never work on energized circuits unless absolutely necessary, and always de-energize the circuit whenever possible. If you are unsure about any aspect of an electrical installation, consult with a qualified electrician or engineer. Electrical work can be dangerous, and it is always better to be safe than sorry. The context and the intent of the National Electrical Code are rooted in the pursuit of safe and reliable electrical systems. The regulations outlined, such as those in 240.33 and 240.81, are not arbitrary rules but carefully considered guidelines designed to minimize the risk of electrical hazards. The code evolves over time in response to new technologies, materials, and installation practices. This is why staying updated is so crucial. Consider the materials used in circuit breakers and panel boards. Over the years, there have been significant advancements in the types of plastics, metals, and insulating materials employed. These advancements have led to improved performance, durability, and safety. The NEC reflects these changes by incorporating requirements that address the specific properties of these materials. For example, the code may specify the types of materials that are acceptable for use in certain applications, or it may establish performance standards that these materials must meet. Insulation practices also play a critical role in the safety and reliability of electrical systems. The NEC provides detailed instructions on how to properly install various types of electrical equipment, including circuit breakers, panel boards, and wiring systems. These instructions cover a wide range of topics such as conductor sizing, overcurrent protection, grounding, and bonding. By following these instructions carefully, electricians can ensure that electrical systems are installed in a safe and reliable manner. Over the years, there have been significant changes in installation practices, driven by factors such as technological advancements, cost considerations, and safety concerns. For example, the use of arc fault circuit interrupters, or FSIs, has become increasingly common in residential wiring systems. FSIs are designed to detect and interrupt arc faults, which are a common cause of electrical fires. The NEC now requires of size in many areas of the home, such as bedrooms and living rooms. Additionally, the code now addresses the use of energy-efficient lighting systems, such as LED lighting. These systems offer significant energy savings compared to traditional lighting technologies, but they also require careful consideration of factors such as power quality and harmonic distortion. The NEC provides guidance on how to properly install and operate these systems in order to ensure their safe and efficient operation. In addition to the technical requirements of the NEC, it is also important to consider the administrative and legal aspects of electrical installations. Many jurisdictions require electrical work to be performed by licensed electricians who have demonstrated their knowledge and skills through examinations and practical experience. These licensing requirements are intended to protect the public by ensuring that electrical work is performed by qualified individuals. Furthermore, electrical installations are often subject to inspection by local authorities. These inspections are designed to verify that the installation complies with the NEC and other applicable codes and standards. If an installation fails to pass inspection, the electrician must correct the deficiencies before the system can be put into service. The NEC is not just a set of rules, it's a dynamic resource that reflects the ongoing efforts to improve electrical safety and reliability. By understanding the code's requirements, staying updated on the latest changes, and following best practices for electrical installations, electricians, engineers, and inspectors can all contribute to creating safer and more reliable electrical systems. Remember also the importance of clear communication and collaboration among all parties involved in an electrical project. This includes the architect, engineer, contractor, electrician, and inspector. By working together effectively, these individuals can help to ensure that the project is completed safely, efficiently, and in compliance with all applicable codes and standards. Before beginning any electrical work, it is essential to conduct a thorough site assessment. This assessment should identify any potential hazards or challenges that may need to be addressed. For example, the site may contain existing electrical wiring that needs to be relocated or upgraded, or there may be underground utilities that need to be avoided. By identifying these issues early on, you can avoid costly delays and ensure that the project is completed safely and efficiently. During the installation process, it is important to use high-quality materials and equipment. This will help to ensure that the system is reliable and will provide years of trouble-free service. Always follow the manufacturer's instructions for installation and operation, and never cut corners in order to save time or money. Furthermore, it is important to keep accurate records of all electrical work that is performed. These records should include details such as the date of the work, the materials used, and the results of any tests or inspections. These records can be invaluable for future maintenance and troubleshooting purposes. Finally, remember that electrical safety is everyone's responsibility. If you see something that looks unsafe, take action to correct it. This may involve reporting the issue to a supervisor, contacting the local authorities, or simply taking steps to isolate the hazard. By working together, we can all help to create a safer environment for ourselves and others.